Let's take a quick look at question number 6 of the RACE-1 of the Secureum Bootcamp. And we once again are to look for issues present in the code base, and we have 3 options, and all of them have to do with reentrancy. It says A, that reentrancy allows one to drain ether, B, a reentrancy allows one to drain the tokens, and C, a reentrancy allows one to receive new tokens for free. So just a quick recap on reentrancy. Reentrancy usually happens when the checks, effects, interactions pattern isn't followed. So checks are usually some sort of require statements or some sort of if statements that revert if certain conditions of, for example, the input variables don't hold, then it reverts early. Then we have the effects. The effects update the state. So, for example, updating the balances and stuff like that. And then interactions are interactions with other contracts. So these are usually external calls that go to some other contract. And the problem is in reentrancy when either checks and effects, when either effects and interactions have been switched around. So instead of CEI, it's CIE. Or if only some of the effects are applied and later more effects are applied. Either way, it's usually about exploiting the fact that a contract state hasn't been fully updated yet, that it isn't done yet, and this half updated state is then exploited by someone else. For example, this other contract here, so this is one contract, and this other malicious contract could then call in back here and exploit the fact that this state hasn't been applied yet, the state update hasn't been applied yet, these effects. So it exploits the fact that the state is still old, but some other state maybe has already changed, maybe some balance has already changed, but some other parameter that is related to the challenge has not changed yet, and that causes the price function to return incorrect results. And even if this price function would only be a read-only function, what could also happen is that this interaction that we're doing to the malicious contract, it could call another protocol which holds money, and this other protocol, it relies on us reporting the correct price. And now it trusts us that this price is correct and uses this price to calculate some stuff. And now this malicious contract can actually exploit this other contract and maybe drain all of its money because of this incorrect price that we reported because we didn't update the state properly and fully before giving control over to the attacker. And this is called a read-only attack, basically. So this is a reentrancy, or how very roughly a reentrancy looks like, or what it requires. And what it requires is an interaction. So for a reentrancy to ever happen, we need to first call to somewhere else for this other contract then to make malicious calls into us or into another contract that relies on this partially updated state. Now the thing is, if we actually look into our contract here of this race, which is the Secureum token contract, we see that there is actually no external call here. Nowhere in this entire code we are calling another contract anywhere. So by definition, a reentrancy is not possible. And that means it's none of the above. And that's it.